Hi children, how are you? It is our fourth class. Are you ready? In the last class, we discussed about the factors that depends upon the resistance of a conductor. What are the factors that depends upon the resistance? The first one is the length of the wire. The second one is the area of cross section of wire. And the third one is nature of material. How is length and area related with the resistance? That is, the resistance is directly proportional to its length, and is as the length of the wire increases, the resistance also increases. As the length of the wire decreases, the resistance also decreases, and the resistance is inversely proportional to its area of cross section. That is, as the area of cross section increases, the resistance decreases. That also the resistance increases when area of cross section decreases. Hope you clear that. There we get an equation, that is R is equal to rho into L by A. Here rho is a constant, and that constant is called the electrical resistivity of the material of the conductor. Rho is the electrical resistivity. What is the equation for rho? That is, rho is equal to A into R by L. Okay. The unit of resistance is ohm, and the unit of electrical resistivity is ohm meter. Hope you understand that. Then we analyzed the practical applications of resistivity in our daily life, that are in good conductors and in insulators. In conductors such as metals and alloys have very low resistivity. It has very low resistivity. In case of insulators such as rubber and glass, it has high resistivity. Okay. Then we also discussed about tungsten. Tungsten is used for filaments of electric bulb because of its low resistivity. Okay. And copper and aluminum are also used for electrical transmission wire because of its low resistivity. Here we discussed about Ohm's law and factors depending upon the resistance. In the Ohm's law, we get an equation, that is V is equal to I into R. That is, V is the potential difference and I is the current and R is the resistance. Then we get another equation, that is, what is that? R is equal to rho into L by A. That is, R is the resistance, rho is the electrical resistivity, L is the length, and A is the area of cross section. We can write this equation in the form of electrical resistivity, that is, rho is equal to AR by L. These are the equations. Today we will do the problems relating to these equations. Okay, let's start. We can start with a simple problem. It is a direct question. That is, the first question is, how much current will an electric bulb draw from a 220 volt source if the resistance of the bulb filament is 1200 ohm? That is, here it is given the 220 volt source, that is V, or electric potential difference, is 220 volt. Volt is the unit of potential difference, and resistance of the bulb filament is 1200 ohm. That is, R is equal to resistance, R is equal to 1200 ohm. Then we have to calculate how much current. That is, we have to calculate the current. That is, we know the relationship between V, R, I. That is, by Ohm's law, V is equal to IR. Here, V is equal to IR. here we have to find the current. So it becomes I is equal to V by R. I have told you a simple way to find the equations in terms of V, I and R. That is electric potential difference, V, I current and R resistance. From this we can calculate V. V is equal to I into R. Okay, I is equal to V by R. Okay, V by R. Then R is equal to V by I. Okay, here we get three forms of equation. That is, we need here the equation for electric current, that is I is equal to V by R. Then V here given 220 volt by 1200 ohm. Here we get the answer. I is equal to, here the electric current is equal to 0.18 ampere. Here the unit is very important. You have to write the unit of each quantity. It is very important. Okay. So here the electric current is 0.18 ampere. This is a direct question. The next question is the potential difference between the terminals of an electric heater is 60 volt. That is the potential difference. Potential difference between the terminals of an electric heater is 60 volt. That is potential difference means V. V is equal to 60 volt. V is equal to 60 volt. When it draws a current of 4 ampere, here current I is equal to 4 ampere current from the source. What current will the heater draw if the potential difference is increased to 120 volt? What current will the heater draw if the potential difference is increased to 120 volt? That is, here when the potential difference is increased to 120 volt, what will be the current? It is the question. Here the potential difference is 60 volt and the current, when it draws a current 4 ampere. When it draws a current 4 ampere, the potential difference will be 60 volt, and this potential difference is increased to 120 volt. Then what will be the current of the heater? We have to find the current at the when the potential difference is increased to 120 volt. Hope you understand the question. Then we know the equation Ohm's law. According to the equation Ohm's law, V is equal to IR. That is, V is the potential, I is the current and R is the resistance. We can divide these into two situations. This is the first situation and this is the second situation. Okay. This is the first situation and this is the second situation. In the first situation, we have to calculate the resistance here. V, I are given, then we can calculate by using this equation the R, the value of R. Then giving here resistance does not change. So giving the value of R in this case, we will get the answer of how much current is used. V is equal to IR in the first case. That is, we have to calculate the resistance. So R is equal to V by I. That is, V is equal to 60 volt by I is equal to 4 ampere. That is, 60 by 4 is equal to 15. The unit of resistance is, what is the unit of resistance? It is ohm. Okay. Then the potential difference is increased to 120 volt. Now the potential difference is 120 volt and the resistance is, we have calculated by using this information, that is R is equal to 15 ohm. Then what is the current? how much will be the current. That is, we know V is equal to IR. By applying the Ohm's law, V is equal to IR. That is, I is equal to V by R. Now the potential difference V is equal to 120 volt by resistance. Resistance here we calculated, that is 15 ohm. Then the current will be 120 by 15, it is equal to 8 ampere. The unit of current is ampere. Here the current will be 8 ampere when the potential difference is increased from 60 volt to 120 volt. Hope you clear. Then we move on to the next question. The next question is resistance of a metal wire of length 1 meter. Here length is 1 meter is 26 ohm at 20 degrees Celsius. That is the temperature. Degree Celsius is the unit of temperature. Then if the diameter of the wire is 0.3 millimeter, here the diameter is 0.3 millimeter, then what will be the resistivity of the metal? What will be the resistivity of the metal? We have to calculate the resistivity of the metal at that temperature. Okay, at that temperature, that is the temperature here is 20 degrees Celsius. The temperature is not changing. Here the resistance of a metal wire of length 1 meter. Metal wire has a length can be denoted by the letter L. It is 1 meter and the resistance is 26 ohm. Resistance can be denoted by the letter R, that is 26 ohm at 20 degrees Celsius. If the diameter of the wire is 0.3 millimeter, diameter, we know this is a wire, this is the area of cross section, then this is a wire of 1 meter, then this is the area of cross section. The diameter of this wire can be denoted by the letter D, then 0.3 millimeter. We can write, I already told you, milli means 10 raised to minus 3. That is 0.3 into 10 raised to minus 3 meter. We can change it into meter. Milli means 10 raised to minus 3. That is, we can write as 3 into 10 raised to minus 4 meter. Okay. Point become here. Then it become 10 raised to minus 4. Hope you clear that. Then we have to calculate the resistivity. What will be the resistivity of the metal at that temperature? We have to calculate the resistivity. Resistivity is denoted by the letter Rho. Rho is equal to, we have the equation, that is Rho is equal to R into A by L. This is our equation to find the electrical resistivity Rho. That is Rho is equal to R A by L. Here R is given, here L length is given, but no area. But here not given the area. Area can be found out by using, that is D is given. We know D is diameter. Area of a circle is, suppose this is a circle, it has a diameter 3 into 10 raised to minus 4 meter. Then the radius will be D by 2 is, the radius R is equal to D by 2, that is 3 into 10 raised to minus 4 by 2. Then area of a circle, we already studied that area of a circle in mathematics. The area of a circle is equal to pi r square. That is pi into r is given here. That is pi into 3 into 10 raised to minus 4 by 2 all square. Pi into 3 square it is 9. Then 10 raised to minus 4 all raised to 2. All divided by 2 square. That is 2 square 4. That is we can write pi into 9 into 10 raised to minus 4 square is 10 raised to minus 4 into 2. That is 10 raised to minus 8 all divided by 4. Okay, that is rho is equal to R. R resistance R equal to 26 into then A pi into 9 into 10 raised to minus 8 all divided by 4 into L 1 meter. Okay, then we get 26 into what is the value of pi? That is 3.14 into 9 into 10 raised to minus 8 all divided by 4. By calculating this, we will get the answer 1.84 into 10 raised to minus 6. What is the unit of resistivity? That is, the unit of resistivity is ohm meter. So, the resistivity is equal to, rho is equal to 1.84 into 10 raised to minus 6 ohm meter. This is the answer. Then we move on to the next question, that is a wire of given material having length L and area of cross section A. Here a wire is there and the length of the wire is L and area of cross section is A and has a resistance of 4 ohm. The wire has a resistance 4 ohm. What would be the resistance of another wire of the same material? Another wire of the same material but having length 1 by 2. Here the length is 1 by 2 and area of cross section is 2A, 1 by 2L, that is half of the length. Okay, here it is asked a wire of given material having length L and area of cross section A has a resistance of 4 ohm. That is a wire of length L. Length is equal to L and area of cross section here A and the resistance has a resistance of 4 ohm. The resistance of this is 4 ohm. Okay, then what would be the resistance of another wire? There is another wire of same material. This is wire 1 and there is another wire 2 and the length of the wire is half L. That is half of the length of this. That is length of the wire is equal to L by 2. Half of this length and area of cross section is equal to 2A. Area of cross section is 2A. Then we have to calculate the resistance of this wire. Resistance of another wire of the same material having length L by 2 and area of cross section is 2A. Then we can take it as R1. R1 is equal to 4 ohm, the first wire. It can be taken as R2. Then R1 is equal to 4 ohm. We know the equation for resistance is connecting length and area, that is rho into L by A. That is here R1 is equal to 4 ohm, that is R1 is equal to rho into L by A. Here area is A is equal to 4 ohm. Then R2 is equal to rho into L, length L by 2 all divided by area 2A. Okay, it can be written as rho into L by 2 become down, that is 2 into 2A, that is rho into L by 4A. We already said that rho L by A is 4 ohm. From this we have to separate this as rho L by A, that is we can write 1 by 4 into rho L by A. Is it correct? Here length is halved, that is L by 2. Then area of cross section is doubled, that is 2A. That is equal to rho into L by 2 into 2A. That is, we can write as rho into L by 4A. We can write this as R2 equal to 1 by 4 into rho into L by A. Is it right? Hope you clear that. We know that rho into L by A is equal to 4 ohm. So we can write 1 by 4 into rho into L by A is 4 ohm. So rho into L by A is equal to 4 ohm. 4 by 4 ohm, that is 4 by 4, it is 1 ohm. So R2 is equal to 1 ohm. The resistance of the new wire is, the resistance of the new wire is 1 ohm. Okay, hope you clear that. That is, our question is, a wire of given material having length L and area of cross section A has a resistance 4 ohm. We take it as the first wire, that is R1. R1 is equal to 4 ohm. Then the length become half and the area of cross section is doubled, that is 2A. Then what will be the resistance? We have to calculate what will be the resistance. Here we take R. We know the equation for the resistance is R is equal to rho into L by A. We take R1 is equal to 4 ohm. That is R1 is equal to rho into length L by A. That is equal to 4 ohm. Then R2 is equal to the new wire, that is rho into length is halved, that is L by 2 by area of cross section is A is 2A. A becomes 2A, that is equal to rho into L by 2 into 2A, that is equal to rho into L by 4A. Then 1 by 4 gets separated, that is 1 by 4 into rho L by A. We already said that rho into L by A, rho into L by A is equal to 4 ohm. That is 1 by 4 into 4 ohm. That is 4 by 4 ohm. That is 1 ohm. Okay, so the resistance of the new wire is 1 ohm. Hope you clear that. Children, hope you clear these problems. If you have any doubt, please ask me in these problems. These are important problems. You have to do it well and practice it. Okay. Hope you understand these problems. Then we will continue in the next class with a new topic. Okay. Thank you.